So here is another question on equation of motion. So it is given that a stone is dropped into a well of depth 67.6 meters, and the sound of the splash, that is the stone hitting the water, that is heard after a duration of 3.91 seconds. Okay, 3.91 seconds later. We have to find the velocity of the sound of the splash. Okay. Okay, so this is the data which is given. Now let us try to convert it into a proper diagram. So we have a well here, so there is water from a certain level below the ground, and this level is 67.6 meters. 67.6 meters. This is the water level. Okay, this is the water level, this from here to here. Now it is given that a stone is dropped and it strikes the water surface, and then the sound of the splash, the sound wave, the sound of the splash is heard to anyone who is standing. Okay, so here there are two parts. Okay, first, the time taken by the stone to hit the water surface, okay, this is, let's write it as t stone, and this is the first part. The second part is the time taken by the sound, okay, the sound of splash, okay, the sound of splash to reach upwards, to go upwards, to be heard. So that is T splash or T sound, whatever you can call it. Okay, this, there are two parts. Now this time which is given here, the sound of the splash is heard 3.91 seconds after the stone is dropped. That is the total time, that is time taken by the stone to hit the water plus the time taken by the sound of the splash to reach upwards, this. Now we will deal each of these separately. First we'll deal with the time taken by the stone to reach or to hit the water surface. So here we'll be using equation of motion. So here nothing has been mentioned about the initial velocity of the stone. So we will assume that it is dropped from rest 0 meter per second because nothing has been mentioned. Then acceleration due to gravity is acting downwards. Direction of the stone is also downwards, so g will be positive. Okay, so here S is equal to 67.6 meters. So here S is equal to U T stone plus half G T stone whole square. That implies 67.6 is equal to, this becomes 0 because initial velocity is 0 or the stone is 0. So simply half into G, which is 9.8, into T stone whole square, which is equal to 4.9 T stone whole square. That implies time taken by the stone to hit the water surface is equal to 67.6 by 4.9 root over, which is equal to, it is coming around, if we calculate, it is coming around 3.71 seconds. Okay, so the time taken by the stone after it is being dropped to hit the water surface up to this, that is equal to 3.71 seconds, the downward journey. Okay, the downward journey. Total time after which it is heard is 3.91 seconds. So the time taken for the sound of the splash to reach upwards, that will be equal to, splash will be equal to T total minus time taken by the stone for the downward journey. So it is 3.91 minus 3.71, which is equal to 0.2 seconds. This is the time taken for the sound of the splash to reach upwards after the stone hits the water surface. Now here another important concept comes into play, that sound, okay, the sound of splash, it travels upwards with uniform velocity. That is very important, uniform velocity. Okay, so velocity of sound is uniform, constant. Time taken for the splash or the sound is 0.2 seconds. Distance which it has to cover is the depth of the well, that is, this distance which the sound has to cover is 67.6 meters. Time is 0.2 seconds. So velocity of the sound will be 67.6 meters by 0.2 seconds. Okay, this much. So that will be equal to 67.6 divided by 0.2, that is equal to 338 meters per second. That is the velocity of the sound. So here the time taken for the sound to reach upwards is 0.2 seconds, and from that we determine the velocity of the sound moving upwards as 338 meters per second. So here again it's a combination of some important concepts. First, the motion of the stone going downwards, that is motion of an object under the influence of gravity, zero initial velocity, acceleration and direction of motion in the same direction, g is positive. We use the basic equation of motion, this ut plus half at square, so a replaced with g, use 0, and we got the time taken for the stone to hit the water surface. Then from that and the data given in the question, we determined the time taken for the sound to move upwards. Then came the second part of the question, the second important concept, that sound travels with uniform velocity. So from that we determined the velocity of the sounds, because the distance which the sound has to cover, that was the depth of the well, that was known. Time taken for the sound to reach upwards, we determined, we calculated here, and from that we determined the velocity of sound of the splash to reach upwards. Okay, so this is the solution.